Okay, this will be a film of number 5, 6, and 7. Number 5, we have 2 boxes of the same mass. Immediately, I'm a little bit suspicious. And it says that kinetic energy is conserved. So we know that this is an elastic collision. So they have the same mass, so we can say mass A is equal to mass B is equal to just M. The initial velocity of box A, so V1A, is 8 meters per second. And box B, V1B, is negative 4 meters per second. After the collision, what are the velocities of each box? Okay, in classic elastic collision fashion, these are going to swap velocities. So this velocity is going to go there, and that velocity is going to go there. So this will be negative 4 meters per second, and this will be 8 meters per second. And you can only swap those with an elastic collision. All right, number 6. A 16 kilogram ball is traveling, so mass A, 16 kilograms, V1A, 5 meters per second, and hits a 7 kilograms, so that would be B, initially at rest. So V1B is equal to 0. If the collision is elastic, all right, so I don't even have to figure it out here. What is the kinetic energy before and after the object makes contact? Okay, well, couple things. We know that in an elastic collision, kinetic energy is conserved. So the KE before is equal to the KE after. Okay, so I don't have any of the after stuff, but what I can do is look at the KE before. And that would be 1/2 MA V1A squared plus 1/2 MB V1B squared. And we know that this is going to be 0 because I have a 0 velocity. So my KE before is just that value. So let's go ahead and plug in. I have 1/2 16 kilograms times 5 meters per second, quantity squared. So I'm just going to square that 5, so that becomes 25. Half of 16 is 8, so 25 times 8 gives me 200. So 200, and because this is energy, I'm talking about joules. So because when kinetic energy is conserved, it's the same before and after, this has answered essentially both questions just by looking at one side of it. All right, number 7, an 8 kilogram cart initially moving at 11 meters per second collides with a stationary 5 kilogram cart. After the collision, the 8 kilogram box travels 8 meters per second. I am suspicious that this is inelastic, but we won't know until we actually take a look at the kinetic energy. So mass of A is 8 kilograms, and its V1A is 11 meters per second. Mass of B is 5 kilograms, and it's stationary. Stationary meaning at rest. So V1B is going to be 0. Excuse me. After the collision, the 8 kilogram, which is this one, so V2A is going to be 8 meters per second. So we lose a little bit on that V2A, so we're going to have some value on V2B. That's what we're looking for. All right, so let's go ahead and look at our equation. So we have mass of A, V1 of A, plus mass of B, V1 of B, is equal to mass of A, V2A, plus mass of B, V2B. It does not say they collide and stick together. It doesn't say that they're together and they break apart. So excuse me, I'm just going to go ahead and use the law of conservation of momentum. It does say that this is at rest, so I can get rid of that. I want to find V2B. So I'm going to take this value and subtract it from here, and then I'm going to divide both sides by that mass. So it looks like this: massive A V1A minus massive A V2A all over massive B is going to equal V2B. Massive A is 8 kilograms times 11 meters per second minus 8 kilograms times 8, I believe. Yeah, 8 meters per second. And then all of that is going to be over 5 kilograms. So V2B is going to be, let's get this worked out. It is going to be 4.8 meters per second. Okay. All right. So now we have all of our values here. I'm going to erase this little guy and I'm going to put in 4.8 meters per second. All right. Was kinetic energy conserved, and what does this tell you about the type of collision? Okay. So I'm going to put a line here to kind of separate before and after. We know that before there is no, right? So KEA1 plus KEB1. And this is going to be KEA2 plus KEB2. KEB1 is 0 because my velocity is 0. So I'm looking at the beginning of just KEA1, so that's going to be 1/2 mass of A times V1 of A squared. So it's going to be 1/2 8 kilograms times 11 meters per second quantity squared. So that's 121 times 4. So we get 484 joules. So this is before. And then now let's go ahead and figure out the after. So we have 1/2 MAV2A squared plus 1/2 MBV2B squared. All right, so 1/2 8 kilograms times 8 meters per second quantity squared plus 1/2 5 kilograms times 4.8 meters per second quantity squared. Let's see here. This is going to be 256 joules. This is 57.6. Let me double check that second one just to be sure. It doesn't look, it looks a little odd. So 0.5 times 5 times 4. Yeah, 57.6. That's what it is. So when I add those together, I end up with a total of 313.6 joules, right? So I'm going from 484 down to 313. So the answer here would be no, it's not conserved. What does that tell you about the type of collision? It's inelastic. Because that's our kind of catch-all for everything else. If it's not elastic or perfectly inelastic, then the default kind of falls down to inelastic.